Hello and good morning, dear students. Now we are moving to last point of chapter number 2. So that point is orbits of artificial satellites. So you know that artificial satellites are used for communication purposes. So for most of the cases, that signals that we receive in our mobile phones that came from that artificial satellites. So we are going to discuss their motion. Means first of all, how we are going to launch those satellites. So in previous chapter, we studied in a rocket motion. There are multi-stage rockets. Rockets are used to launch various satellites at particular height, and after that launch, we can use those satellites by giving them some certain horizontal movement. We keep those satellites in certain orbit. Okay, so from those satellites we can get various applications in communication purposes. Now first of all, for this case, artificial satellites energy is equal to v prime minimum. That is the first requirement. Another requirement is that orbit must be circular. Okay, so for artificial satellite, orbit is approximately circular. So suppose this is earth and this is center of earth and satellite is over here. Suppose capital M is mass of earth, which is 6 into 10 raised to 24 kg, and small m is the mass of that satellite. So mass of satellite must be around some 100 kg, 200, 500 kg, 1000 kg, like this. Now if r is the distance between satellite and earth from center. Okay, suppose this is radius of earth, and we know that suppose this is rh is the height of that satellite from earth's surface. Eventually we are going to launch satellite from earth's surface. That's why we need to know what is the value of rh. Now in this case, since this satellite is revolving under circular motion, so for this satellite, this is a bounded type of motion, and when that satellite is moving, for that case centripetal force is balanced by gravitational force between those two. Okay, now since in satellite and earth there is only one type of force, which is gravitational force, and we know that gravitational force is a central force. So centripetal force is equal to gravitational force. So what is the gravitational force between earth and satellite? That is given as capital G into capital M into M divided by R square. Okay, so this is the gravitational force. Capital G is universal gravitational constant. We know that its value is 6.67 10 raised to minus 11 in MKS unit. Capital M is mass of earth, small m is mass of that satellite divided by r square. R is the radius of that path. Now centripetal force is, we know that mass of that satellite into velocity of that satellite divided by r. So v square upon r is the circular acceleration. If you multiply this circular acceleration with mass, we will get centripetal force. So this small m will get cancelled, which is mass of the satellite. So from this equation, this r and r square get cancelled. So v is equal to, v square is equal to what? Capital G divided gm divided by r, and this is v square. If you take square root of this, so that will become square root of gm upon r. Now remember, velocity of that satellite is depends on capital G constant, capital M mass of earth, which is constant, divided by r, which is radius. If you keep radius lower, then velocity is maximum. If you keep this radius higher, then this velocity becomes lower. So since velocity is a reciprocal of square root of r. Now for this circular motion, time required to complete one oscillation or one complete this circle is capital T. We know that time, which is known as periodic time. Okay, so here capital T, which is periodic time, that is given by taking velocity to be constant, t as we can find out this t as we know that velocity is distance divided by time. Okay, so time is equal to distance divided by velocity. Now to complete one this complete rotation, the distance is 2 pi r, which is circumference of this circle, divided by, if you take this time over here, then velocity goes to denominator divided by v. Okay, so from equation 1 we can write t is equal to 2 pi r divided by v, and v is nothing but square root of gm divided by r. Okay, so here we can write as r upon gm. Now if you take this r into this square root, so that will become r square. Okay, so you can write this r as r square, though this r square and r, so that will finally become r cube. Okay, in the square root. Now squaring, what we will get? So t square is equal to 4 pi square into r cube divided by gm. So this is equal to 4 pi square gm into r cube. So this whole term is again constant. T is what? Periodic time. So square of period of revolution of that satellite is this constant, capital G is constant, M is constant into r cube. So r is the radius of that path. So t square is directly proportional to r cube, and remember this is nothing but Kepler's third law. So satellite, although it is moving in certain orbit around Earth, so that satellite also satisfies Kepler's third law. Now, geosynchronous orbit. So first of all, definition of geosynchronous orbit is that orbit in which periodic time is 24 hours. We know that Earth rotate around itself in 24 hours. If satellite is having periodic time of 24 hours, then we can say that orbit is geosynchronous orbit. Now, for geosynchronous orbit, if you put in this equation t as 24 hours, we can calculate capital R. Okay, so call this as equation 2. So from equation 2 we can write r cube is equal to capital Gm divided by 4 pi square into t square. Okay, now if you take r, so that is cubed root of this. Now this is equal to, using values, mk's values, we know that universal gravitational constant have value 6.67 into 10 raised to minus 11. Mass of earth is 6 into 10 raised to 24 kg divided by 4 pi square into t. So as I told you, capital T is 24 hours for that geosynchronous orbit. So we can put 24 hours into seconds. So 24 into 60 into 60. So this is 24 hours. This is, if you multiply to this into 60, so that will convert into minutes. So again by multiplying 60, so this will convert into seconds. So we have to take cube root of this. Now using calculator, if you solve this and get value, you will get answer around this. Now this answer is in kilometer, so you will get into 10 raised to 3 answer, which is in mks unit. So I'm going to write directly answer, confirm this answer from your calculation. 42,241.2 kilometer. So this much is the height, okay, from center of earth. Remember, r is the distance from center of earth. Now to find out rh, So RH means radius or distance above Earth's surface is r minus radius of Earth, and that is given as 42,241.2 kilometer minus 6,400 kilometer. So this is the radius of Earth. So we will get answer 35,871.2 kilometer. So this is the height above Earth's surface. Now, if you want to take geosynchronous orbit, then we have to take that satellite at a distance of 35,871.2 kilometer above Earth's surface. Now, geostationary orbit. So, again, geostationary orbit is a geosynchronous orbit or geostationary satellites. What is known as geostationary satellite? So, geostationary satellite having periodic time of 24 hours. So, it is stationary, okay, with respect to Earth, and distance above Earth's surface is 35,871.2 kilometer. Okay, so the satellites which are in geosynchronous orbits are known as geostationary satellites. Why? We know that Earth rotate in 24 hours. If you keep that satellite on the surface of Earth, so as Earth rotate, that satellite also rotates. So that satellite is stationary compared to the point on Earth. So those satellites are known as geostationary satellites, and such type of satellites are used in communication and defense purposes. So if you want to see certain storms which are coming out of certain oceans, or you want to focus on certain areas, okay, in which battle is going on, then you can put that satellite over there for survey purposes, and you can point out those areas and see from Earth. So with this, our this chapter number 2 is over. Now we are going to solve problems on chapter number 2. So first problem I already written over here. See, first problem is a particle describes a conic section which is given by equation L upon R is equal to 1 plus E cos theta, where L is semi-lattice rectum and E is eccentricity. Show that force under which particle is moving is central force, that we have to prove. So in solution of problem number 1, what is given L upon R is equal to 1 plus E cos theta. Now to get law of force, because if we want to show that force is central force, then we must know what is the law of force. So to get law of force, we must need to solve differential equation of motion. Okay, so differential equation of motion is d2u by d theta square plus u is equal to minus m divided by L square u square f of 1 over u, with u is equal to 1 upon r. Okay, so now put u is equal to 1 upon r in equation 1, because that is given. So put in equation 1. So what we will get? So L upon R, okay. So L upon R can be written as 1 upon R is equal to 1 plus E cos theta divided by L. Okay, if you take this L on the right hand side, so 1 upon R is nothing but U. Okay, now we have to use this U in equation 2 and find out f of 1 over u. So for that we must need to know second order derivative of u. So differentiating with respect to theta, we get, so first order derivative du by d theta is equal to, so e upon L derivative of cos theta is minus sin theta. Okay. So again differentiating with respect to theta, what we will get, du by d theta square is equal to, now minus e upon L derivative of sin theta is cos theta. So put in equation 2. So what we will get, so d2u by d theta square, so for that we will get minus e cos theta divided by L plus u, and u is nothing but 1 plus here e cos theta divided by u, that is equal to minus m divided by L square u square f of 1 over u. Okay. Now we have to solve this equation. So for that, if you solve this, denominator, the base is same, so minus e cos theta plus e cos theta, so that will become 0, so 1 upon L. Okay, multiply by, if you take this term on the left hand side, so minus L square u square divided by m is equal to f of 1 over u. So put again u is equal to 1 upon r. So f of r is equal to minus, what you will get in this equation, minus L square. Okay, this L will cancel, so L divided by m into u square. So L is constant, m is constant, and u is 1 upon r, so 1 upon r square. So what is law of force? So force is directly proportional to minus 1 over r square. Now when force is directly proportional to 1 over r square with negative sign, which means this force is attractive force, and 1 upon r square. So for such forces, we know that such forces are conservative forces and central forces. Why? Because gravitational force is having 1 upon r square dependence. Again, electrostatic force is having this dependence. So therefore, force is conservative. Okay. Now, with this, we finish our lecture over here. In our next lecture, we will solve remaining examples. Thank you.